Hi everyone in Algebra 3. This is going to be your video on the new material in lesson 60, which is on factorable trig equations and then loss of solutions caused by division. We're going to go over some of the new problems in the examples as well as going over some of the new problems in the lesson. In addition to that, we're also going to go over some of the new problems that we learned in lesson 59. So hopefully you watch this video before you try and finish your lesson and before you ask your questions. In the comments of this video is where you're going to place all of your questions on lesson 59. So the first thing that we're going to look at is factorable trig equations. So something that you've seen before in the past was if you saw x squared minus 1, you know that that can factor into x plus 1 times x minus 1. It's also called the difference of two squares. You can take the square root of x squared and you can take the square root of 1. And that's how you factor those. Then your solution for x would be negative 1 and 1. Looking at the second one, I have x squared plus x. Well, I see that there's a common term of x in both of these, so I can factor these into x and then x plus 1. Then when you're solving, you would have x is equal to 0 and then x is equal to negative 1. This is going to work the same as when we are solving for our trig functions. So when we see sine squared minus 1, this is the same thing as x squared minus 1. So instead of an x plus 1 and x minus 1, you would take the square root of sine squared, which would be sine x plus 1 and then sine x minus 1. And then you would set each of those equal to 0 and then solve. For this next one, I have tangent squared x plus tangent x. Now to solve for this one, you would see that there's a tangent in both of these terms. So I would factor a tangent out. And then you would set each of them equal to 0 to solve. Okay, so factorable trig equations. The next thing we're going to talk about is called loss of solutions caused by division. You can never divide off a trig function. So in this trig function here, we have 2 sine x cosine x equals sine x. You cannot divide both sides by sine x. But what you can do is you can set this equation equal to 0 by moving the sine x over to the left-hand side, and then you can solve from there. So you can never divide off a trig function. So remember to pay attention to that. You cannot divide off a trig function. So what we're going to look at here is number 7 and number 8. These are, after you factor, they're going to look very similar to the ones you've been doing in the past. So the first thing that you're going to look at for number 7 is that you see that there is a cosine squared minus cosine theta is equal to 0. And our answer needs to be between 0 and 360. So the first thing that I recognize is that there's actually a cosine in both of those terms that I could factor out. So I'm going to factor out cosine theta. When I do that, this cosine theta, cosine squared theta, goes down by 1 and becomes just cosine theta, and then minus 1 is equal to 0. So essentially, I factored out a cosine theta out of both of those terms. Now what you're going to do is you're going to set each of these equal to 0. So I'm going to have two different functions that I'm solving for. I'm solving for cosine theta equals 0, and then cosine theta minus 1 is equal to 0. Now when I move the 1 to the other side, I get cosine theta is equal to positive 1. But now I have to solve. And I know that there is no reference triangle that would have an adjacent of 0 and a hypotenuse of 1, or an adjacent of 1 and a hypotenuse of 1. So really I'm going to my unit circle. I'm going to draw up my unit circle, and what I need to recall is what is cosine equal to on the unit circle? Well, cosine is equal to the x coordinate. So I'm going to go through and I'm going to underline all my x coordinates. So for this one, I'm going to be looking for where my x coordinate is equal to 0. Well, if I look at this chart, there are actually two places where x is equal to 0. At 90 degrees and at 270 degrees. Then I'm going to look at my second one, where cosine theta is equal to 1. Again, cosine is equal to x coordinate, and I'm looking at all my x coordinates. There's only one place where the x coordinate is equal to 1, and that is at 0 degrees. So my answers are going to be 0 degrees for what satisfies for when cosine is equal to 1, And then when cosine is equal to 0 would be at 90 degrees and at 270 degrees. And those would be your answers. Now I want you to look at number 8 on your own, and then you can unpause this video once you have attempted it. So number 8, the first thing that I'm going to do is I'm going to move the 1 to the other side. So I get sine squared theta is equal to 1. Now in order to get sine so that it's no longer squared, I'm going to take the square root of both sides. But remember that when you take the square root of something, that you don't just get the positive of that value, you get the plus or the minus. So really I end up with 2 equations here. I have sine theta is equal to positive 1, and then I have sine theta is equal to negative 1. Again, I don't have a reference triangle that's going to have an opposite of 1 and a hypotenuse of 1, so I know that I have to use my unit circle. And now I need to remember what sine is equal to on the unit circle. And sine is equal to the y coordinate. So I'm going to go through and underline all my y coordinates. Now for the first one, I'm looking for where is the y coordinate equal to positive 1? At what degree is the y coordinate equal to 1? And if I go through this chart, there's only one place where my y coordinate is equal to 1, and that is at 90 degrees. So that's going to be one of my first answers. And then I'm looking for where is my y coordinate equal to negative 1? At what degree? 0 degree, it's at 0 degrees, it's equal to 0. At sine of 90, it's equal to 1. Sine of 180, it's equal to 0. But look at sine of 270. Sine of 270 is equal to negative 1. So that means that my second answer is going to be theta is equal to 270. So you have 2 answers. Now this concludes your new material from lesson 60, but what I'm going to do is I'm going to go through some of the new problems that we did from lesson 59, and I want you guys to pause the video and try them before you actually watch the rest of the video. So I'm going to look at number 9 first. And if you want to attempt them all, I would do numbers 9 through number 13 before you unpause the video. So number 9, we have a number outside my logarithm. So I'm going to put that to the power. And then if I have a minus sign in between my 2 logarithms, I know I have to divide. So for number 9, I have log 6 of x cubed equals log 6 of 24 divided by 3. Now when I want to get rid of the my log 6, I'm going to raise both sides to the power of 6. So it would be 6 to the log 6, and that cancels. And now I'm left with x cubed is equal to 8. And therefore, x is equal to 2. But what we learned in lesson 59 is that you need to make sure that that works. Now it's equal to a positive value, and if I plug in a positive 2 into here, it does work. The only way it would not work would be if it was, this would become a negative. Now you should have attempted number 10 already. So number 10, I have a plus sign between my 2 logarithms. So in order to combine them, I'm going to multiply those values. So for number 10, I end up with log x times x minus 3 is equal to 1. But I know I have to get rid of that log. And in order to get rid of the log, I have to raise it to the same base. And what you need to remember on this one is that when there's no base, the base is assumed to be 10. So this would be 10 to the log 10, and then 10 to the 1. So now on the left-hand side, when I multiply that through, I'm going to have x squared minus 3x is equal to 10. But I'm going to set this equal to 0 so I can solve. So I have x squared minus 3x minus 10 equals 0. Now if I can remember back to algebra how to factor that, I have 2 numbers that multiply to give me negative 10 and add up to give me negative 3. And those 2 values are going to be minus 5 and plus 2. Which means that I have two solutions for x. I have x is equal to positive 5 and negative 2. But when I go back to the beginning, if I plug in 5, that works here. If I plug in 5 here, that also works there because it would be 5 minus 3. But if I plugged in negative 2, that would become log of negative 2. And again, you can't take the log of a negative number, which means that your only result is going to be that x is equal to 5. Now moving on to number 11. Again, I see a number outside my logarithm and I see a minus sign. And on the right-hand side, this one's tricky. So I'm going to deal with the 2 outside my logarithm first. So that would become log 2 x squared minus log 2. I'm going to make that into a common denominator. So that would be 2x minus 1 over 2 equals log 3. Now I can't actually get rid of my logs on both sides because this one has a different base. But I do know that if my log's base and the base of my number next to it are the same, they actually cancel. So this log 3 and the 3 would cancel, and the only thing that would be left would be 1. On the left-hand side to combine, I'm going to divide because of the minus sign. So that would become log base 2 of x squared divided by 2x minus 1 over 2 equals 1. Now to get rid of the complex fraction, you would multiply by the reciprocal, which would be 2 over 2x minus 1. And at the same time, I'm going to get rid of the log 2 by raising both sides to the power of 2. So 2 to the log 2, and that would cancel. And on the right side, it would be 2 to the 1, which would be equal to 2. Now, I'm going to multiply 2x squared over 2x minus 1 equals 2. And we can put that over 1. Now to solve, I'm going to cross multiply. So that would become 2x squared is equal to 4x minus 2. Well, I can see that this whole thing is divisible by 2, and I'm also going to bring everything over to the left-hand side. So when I do that, I'm going to get x squared minus 2x. This would become plus 1 equals 0. Now, this one actually does factor evenly too, because I have two numbers that multiply to give me positive 1, but when added up, give me negative 2. So negative 1 times negative 1 gives me positive 1, and then negative 1 plus negative 1 gives me negative 2. So my result is going to be x is equal to 1. The only thing I need to do now is go back to the beginning and see if that works. So if I plug in log 2 of 1, well, that works because it's positive. And then 1 minus 1/2 would be positive 1/2, so that works as well. So my result is going to be that x is equal to 1. Now, if you haven't attempted number 12 and 13, I want you to do so now before you press play. So on number 12, again, if my base and my log's base and the exponent are the same, they actually cancel each other out. So 32 to the log 32 of 7. Well, that's what I do on all my other log problems to get rid of my log. So I know that those cancel, and I'm left with just 7. And then for number 13, I see a minus sign in my exponent. So to combine those, I'm going to divide. So for number 13, I have 3 to the power of log 3 of 6 divided by 2. Now, again, notice that I have 3 in my base and log 3 in my exponent, which cancels. So I'm left with 6 divided by 2, which is also equal to 3. And that will conclude your new material from lesson 60. If you have any questions on your lesson 59, please make sure you end up putting those in the comment section of this lesson. Have a great weekend.